Over the next few clips, I will attempt to explain variety of problems and situations where we have to use an Argand diagram to represent vectors, complex vectors, or questions involving Argand diagrams and complex numbers. By no means is this an exhaustive list of all possible questions, but I will attempt to clarify quite a few of them. So let's first consider two vectors, z, and let's say z is a plus ib and w c plus id. Now, a question is, what does z plus w really mean on an Argand diagram? So let's draw two vectors, and let's say here's my z, here's my w. Now previously we've discussed that these two vectors, when they're added together, they form a parallelogram. But why? Excuse my diagram. You can see that the sum of those two vectors results in a third vector. So if this is my z and this is my w, then what's happening is we're starting with z, heading up to here, and then adding w, so the tail of w sits at the head of z, and then the vector is drawn, and wherever we end up with is the new vector z plus w. So if we have a look at algebraically what that means, that's a plus ib plus c plus id. The real part is a plus c, and the imaginary part is b plus d. Now let's look at what's happened on our vector diagram. That would be a, this would be b, here's c, and here's d. When I add these two vectors, c and a get added together, so the resultant is a plus c. And my diagram's not quite perfect, but you can see what's happening. And then the same is true for the imaginary part of the addition, where we're adding a b and d, so that d gets added on top, b plus d, resulting in the new position. When we do a vector addition, then we're just taking the real values of a and c, which I've lost here, and we're adding those two together, and we're taking b and d, and we're adding them together to find the position of the new vector. So that's addition. What about subtraction? Now subtraction seems a bit confusing, but if we go back to our algebraic format of how this works, then you can see that we'll end up with a minus c plus I b minus d. So what we're doing is taking the real value of the second vector away from the real value of the first, and similarly the imaginary parts are being subtracted. So how does that look on a vector diagram, on an Argand diagram? So this time I am going to set this as my Z, and here's my W. That would be A. Maybe I should extend my W so that the values aren't so close to each other. Let's make that our W. This is our B, C, and up here would be our D. Okay, so we are subtracting C from A. So that would leave me with a point along here. Maybe that's not the most accurate. Let's see. Here is C, and I am subtracting A amount from it. So we're going back A amount would be around here. And then from B, I am subtracting D amount. So starting from here, from where my B is, I am going to subtract D amount. So I would expect to be somewhere around here. So my resultant vector is down here. Now you can see when we talked about this in class, it's the same vector as up the top joining W to Z.